Today we're going to do product and quotient rules together. The product rule, given the function y equals f of x times g of x, when two things are multiplied together, the derivative dy dx is equal to derivative of the first function times the second function plus the first function times the derivative of the second function. So it's written, I memorize it this way. It's written a little differently in your formula booklet, and we'll talk about that in a second. The quotient rule is f prime times g minus f times g prime over g squared. So here, the product rule, if you memorize it this way, then there's a plus sign, and here it's a minus sign. That's the only difference, and you divide by the denominator squared. Okay, here's how it's written in your formula booklet. So if the function y is u times v, then it's u times derivative of v plus v times the derivative of u. And if the function is y equals u over v, then it's v times the derivative of u minus u times the derivative of v divided by v squared. So it's written there, but you don't want to go back and forth. So this is something that you want to commit to your memory. All right, let's do some questions together. So we see that here, we want to find the derivative of these three functions, and y equals e to the negative 4x times sine of x. Notice that this is not this. These are two functions multiplied together, and there's a little bit of chain rule. There's a composite here because instead of being e to the x, it's e to the negative 4x, but that won't be too difficult. So here, we are going to use the product rule. So how do we find the derivative of y? Well, we take the derivative of the first function, so that would be negative 4 e to the negative 4x times the second function plus the first function times the derivative of the second one. Okay, so that would be your derivative of y. You can factor out e to the negative 4x, but I don't know if that's completely necessary. Okay, here I am going to rewrite this function as x to the 1/3 times cosine of x. And you can still see that you're multiplying two functions together. So we are going to use the product rule. So what would f prime be? Well, f prime of x be derivative of the first term times the second function plus the first times the derivative of the second function. Okay, we won't worry too much about combining the terms here. We'll just simplify so that we don't have negative exponents. Okay, something like that. The third function is y equals e to the x over natural log of x. Okay, so maybe we can write here derivative of e to the x is e to the x, and then derivative of natural log of x is 1 over x. And this might come in handy in a second. So what is the derivative of e to the x over natural log of x? Well, dy dx is equal to derivative of the top function. So here you can go back and look. Derivative of the top times the bottom function minus top function times the derivative of the bottom over the bottom squared. So derivative of the top, just e to the x, times the bottom function minus the top function times the derivative of the bottom function over the bottom function squared. Okay, of course you can simplify this further. You can factor out the e to the x That's going to be natural log of x minus 1 over x over natural log of x squared. So there, that's how you use the quotient rule to find the derivative. Let's try this question. Find the slope of the tangent line to the function f of x equals e to the x ln x. Well, you can clearly see that these are two functions multiplied together, so we are going to use the product rule. So f prime of x is going to be derivative of the first one times the second function plus the first function times the derivative of the second function. Okay, but we want to know the slope of the tangent line when x is 1, so we want f prime of 1, that would be e to the first power times natural log of 1 plus e to the 1 times 1 over 1. But here, the natural log of 1 is 0, so that goes away. So we have e. The slope of the tangent line of f of x at x equals 1 is e. Next, here we have a function f of x is equal to x cubed plus 1 over cube root of x. So it looks like we're going to have to use a quotient rule. But whenever you have a denominator with x to the some power, then you actually don't have to use quotient rule. I think it's even better if you rearrange it or somehow simplify it to make it fit the power rule. And here's what I mean. So instead of this expression, I am going to rewrite it like so. And then this is x to the 1/3 power. And I'm going to combine these expressions into one. So x cubed divided by x to the 1/3 is x to the 3 minus 1/3. So that would be x to the 8 over 3. And here it would just be x to the negative 1/3. So there. So before I start finding the derivative, I can simplify it to make it easier, right? So now I can find the derivative using the power rule, which is a lot easier. There. So the trick here is just because it's written this way, it doesn't mean you have to use the quotient rule. If you simplify it and use a power rule, it's going to be a lot faster and maybe even more accurate because there's a less chance of you making a mistake while using the quotient rule. Okay. So here are two examples. Here it looks like you're going to have to use a quotient rule, but again, you can also rewrite this as x to the negative 3 times e to the x. So you can actually use a product rule if you prefer. So I'm going to do this one with the product rule. F prime of x would be derivative of the first one, negative 3x to the negative 4 times e to the x, plus the first function times the derivative of the second one. Okay, then you get negative 3e to the x over x to the 4th plus e to the x over x to the 4th. X to the 3rd, sorry. There. You can combine it and simplify more, but if your goal at the end is to find the slope of the tangent line when x value is a certain number, then it really wouldn't matter. But I'm going to go ahead. Let's go ahead and simplify. Okay. That would be e to the x minus 3 over x to the 4th power. try algebraically putting it together and see if you can get this one. All right. Next question, our last question, is sine x over x squared. You can certainly use the quotient rule, and you can also change this expression like I did in the first question and make it into a product rule. I'm going to use the quotient rule. Well, let's do it both ways. First, I'm going to use a quotient rule. So derivative of the top function times the bottom function minus the top function times the derivative of the bottom function over the bottom function squared. Okay, so that's our derivative, and using quotient rule, I think you can simplify further. Let's try that. I might even separate these. So here you get cosine x over x squared minus 2 sine x over x cubed. Okay, so that was using the quotient rule, and now let's change h of x to x to the negative 2 and times sine x, and that way we can use the product rule. In this case, it'll be derivative of the first one, negative 2x to the negative 3, times the second function, plus the first function times the derivative of the second. Okay, so we'll see. That's going to be negative 2 sine x over x cubed plus cosine x over x squared. So the terms are switched, but it's exactly the same as that one. Okay,